you learned that something like this is called a monomial, a single numeric slash letter thing, okay? You learned that is a binomial because it has two monomials in it. And you also learned that this is a trinomial because it has three things in it. Now, the reason that this is not added together is because, like the colored pencils, this is a different item than that. In the same way, these three items are different. This is a y cubed. There happens to be 4 of them. This is an x. There happens to be 3 of them. And this, since it does not have a variable, is called a constant. A normal number is called a constant. So what you are learning about today is how to add and subtract polynomials where necessary. Okay? Let's look at the money sample. You're saving up to go to Costa Rica where there's a volcano exploding. You deposit $500 into your account that earns interest compounded annually. 1 year later, you put an additional $600 in there. Let R, the letter R, represent the interest rate. What will the balance, A, they're just using letters to represent things. What will the balance be of the account 2 years later? In example 2, you're going to find that out. In example 2, you're going to find that out. But for simple purposes, we're going to start with example 1. You think that that question is really hard, but it's not. Example 1. If I give you, and if you don't copy this and follow along, it's going to be really hard for you to make sense of this later. So make sure you copy along and listen to what I am saying to you. If I say to you, add this item with this item, that should be minus. First, make sure you've copied everything correctly, as in positive signs, negative signs. Okay? Once you verify that you do that, you've done that, look for your operator. And what I mean by operator is, are you adding or are you subtracting? That operator is addition, which means I am combining. You're going to hear me use the word combine a lot. I am combining this with this. Now, the key to proper algebraic addition when you are adding or when you're adding subtracting polynomials is to make sure you add the correct colored pencils together. All right? The easiest way for me to represent this, I like to use my colored pencils, is notice that this and this are both the same thing. Those are both x cubes. Would you agree with me? Mm-hmm. If I look at a negative 8 x cubes and combine it with a positive 3 x cubes, I end up with negative 5 x cubes, right? Look at it again. There's a negative 8x cubes in the first polynomial, and there's a positive 3x cubes in the second polynomial. Combining the amount of x cubes, and you end up with a total of negative 5 x cubes. Once I've done one set, I usually cross them off. The next set. Looks like I have some x squareds, don't I? How many x squareds, Ben, are in the first polynomial?
4.
Mm-hmm. And Rachel, how many x squareds are in the second polynomial?
2.
Negative 2. Watch out for those signs. So if I combine a positive 4 x squareds with a negative 2 x squareds, How many x squareds do I have?
-2.
2. Positive 2. Positive 4, negative 2. Does everybody understand why I came up with that? Lizzie, are you good over there? Ben? Okay. Once I've combined them, I cross them off. The next item up for bids are x to the firsts. Mrs. Meyer, I don't see x to the first. Yes, you do. If there's no number, it's understood that it's to the first. If there is no exponent, it is understood. So right here I've got how many x's? 1. Again, if there is no number, there is 1 of them. And how many x's do I have over here? 0. 1 plus 0 is how many?
1.
So I have 1 of them. Remember, I don't write the number 1. You can, but you do not need to. It is understood, if I list it, that there is 1. Once I'm done with it, cross it off. Finally, how many constants are there here? There's 1 here, 7 there. All together?
8.
Yeah, I know. 8, right? All together. So, the grand total of this adventure is negative 5x cubed plus 2x squared plus x plus 8. You cannot combine any further than this because this is green colored pencils, this is red colored pencils, this is orange colored pencils, and this is a black pen. Okay, you cannot group them any more than that. Okay, this is as specific as you can get. That was A. Let's do B. Okay, if you look in the book, you might notice that they used stacking column-like addition. We can do that as well. You can either leave them like this and mentally group the things together that are the same, or you can stack them. So I'm going to stack these two so that you can see them. First, I'm going to list the first polynomial. And it looks like this. Make sure you're writing it. If you're just sitting there staring, you will not understand this. Okay, so here's the first polynomial. And it is being added to this polynomial. This means that x cubed is a positive. Okay, in case you're wondering, well, wait a minute, I'm not sure about the sign of this x cubed. That means that's a positive. So x cubed minus 3x squared plus 2x plus 1. The x cubed goes underneath the other x cubes in the first polynomial. Does this polynomial have any x to the fourths? Yes or no? No. X cubed, x squared, x to the first, and a constant. There is no x to the fourth. If you want to put a placeholder, do it. If you don't, well then be careful, because otherwise you could possibly put things under the wrong thing. X cubes go under x cubes. X squareds go under x squareds. X to the firsts go under x to the firsts. Constants go under the constants. And now you can add. Think of this as a placeholder, just like you would think of that and that as a placeholder, right? Without those two zeros, you would be adding 16 to 32. Without those two zeros, you would be adding 16 and 32. Clearly, you would not have the right answer because you would be adding the wrong number, you would be adding hundreds to hundreds, and you would think, or you would be adding the wrong place values together. Blah, blah, blah. Let's add. 2x to the 4th plus 0. What do you think, guys? 2x to the 4th. 6x cubed plus x cubed. What do you get?
7x cubed.
7x cubed. Jessica, what do you get in the x squared column as your end result? Negative. Has to have the right sign. 8x squared. Gage, what are you getting in the x to the 1st column?
3x.
Mm-hmm. Michael, what are you getting in the constant column? Mm-hmm. My writing sort of shrank as I went along. There's your answer. Okay? That is all we are doing when we add polynomials. Okay? We've just added polynomials together. We took this one and combined it with that one. Okay? That's adding polynomials. Now, you could either use this vertical column format, or you can do your, in your head, group together your x cubes. In your head, group together your x squareds. I don't really care which way you do it. Even if it says, write them vertically, I don't care how you do it. Okay? I'm going to skip example 2 for right now. I'm going to skip example 2 for right now. But I am going to go down to, just to show you something, checkpoint 5 and 6, middle of page 658. Notice they call the right-left combining the horizontal format. Okay, notice they say, find the sum using a horizontal format. This one here, I taught you using the vertical format. I taught you that one using the vertical format, and that's what they ask for in the first checkpoints. I don't care which method you use, whatever works for you. Does that make sense? Mm-hmm. Okay. Before I get to example 2, I do want to do example 3. Okay? So I skipped example 2. We are on to example 3, which is subtracting polynomials. Okay? Think of subtracting as removing, right? When you go to the grocery store, you receive groceries by removing money from your pocket, right, and giving it to the people. Or if a thief comes up and sticks his hand in your wallet, he's going to remove or subtract money from your wallet. God forbid, right? The word remove is an important word to use, okay, with subtracting polynomials. And I'm going to try and show you why in examples 3 and 4. Examples 3 and 4. Starting with example 3, find the difference. 6x squared plus 4x minus 7 is the minuend, from which we are removing 2x squared minus x plus 8. Okay? Subtracting polynomials is very tricky for some people. In subtraction, the easiest way to think is add the opposite of the subtrahend, which is the second item. Let me illustrate it. 62 minus 12. All of you know how to do this. You've been taught it since you were little. You would say 2 remove 2 is 0. 6 remove 1 is 5. Right? But what if I said to you, add the opposite? Instead of subtracting a 12, we're going to add a negative 12. Would you get the same thing?
Yeah.
Of course you would. Okay? So this is an example of adding the opposite of the subtrahend, which is the second item in a subtraction problem. To do that with this, Step 1, copy the minuend. Okay, this is the minuend. This is the subtrahend. Okay, 6x squared plus 4x minus 7. Okay, write down the subtrahend. It is 2x squared minus x plus 8. Okay, so step 1, write the minuend. Step 2, write the subtrahend. We are subtracting, right? Instead of subtracting, I want you to add the opposite. The easiest way to make sure you do that correctly is to use another pencil, another color, and do this. Add the opposite. Add the opposite. Add, what's the opposite of a positive 8? Negative 8. By using an alternate pencil or pen color, it is much clearer to you, and now it's just like it was when we did addition, the previous example, right? All we're doing is combining. So by adding the opposite, we are performing the subtraction correctly. So let's combine this stuff. A negative 7 and a negative 8. A positive 4 and a positive 1. A positive 6 and a negative 2. Okay, add the opposite is going to be your best friend. Okay, I have some kids that still struggle with this because they weren't taught that. When you subtract, you add the opposite of each item. Okay, let's do another sample. Let's do checkpoint 7. Step 1, write the minuend. What's the minuend in checkpoint 1? It's the first item. What is it? What's the minuend in the first checkpoint, number 7, actually? Yes, 6x squared. Keep going, Jada.
Plus 4 plus 7.
So we did step 1, right? Minuend. What's step 2, Haley?
And the opposite.
Yep, but we haven't written the subtrahend yet, so should we write it?
Yeah.
Let's do it. Haley, tell me what the subtrahend is.
5x squared plus x minus 9.
Okay, we're writing it underneath the same type. And we know this is a subtraction problem. So we list it as a subtraction problem. And then Haley's already told us. What do we do?
And the opposite.
Add the opposite of the subtrahend. Add, what's the opposite of a positive 5, people? What's the opposite of a positive 1? And if you have to make it real obvious, you do it that way. What's the opposite of a negative 9? The negatives are easier to fix. Okay, let's do it. Positive 7 and a positive 9.
16.
A positive 4x and a negative 1x.
3x.
Positive 3x. And a positive 6x squared and a negative 5x squared.
Negative x squared.
Good. All right. I want you guys to do checkpoint number 8 right now. Checkpoint number 8. First, write the minuend. Notice that there is a constant in the subtrahend but not in the minuend. I want to see how you guys deal with that. What I would do is I would put a 0 in the minuend in the constants position just so that you remember that. And I'll show it to you here in a minute. First write the minuend, then write the subtrahend. for the minuend, what I wrote is 14b squared minus 12b plus 0. That way you have a place to line your 1 up with. Once you've written your minuend and your subtrahend, make sure you write it as a subtraction problem. Step 4, add the opposite of the subtrahend. Dun, dun, dun. Did y'all come up with something that looked like that? If you followed the steps, you should have. This whole placeholder business is used whenever you are missing something in one of the items. You insert a placeholder, just like you inserted a 0 in the number 102 because you didn't have a 10. Here we inserted a placeholder here because we didn't have a constant. So we had nothing to subtract this 1 from. And there's your answer. Checkpoint 8. These steps, if you write them down and follow them, will help you. Okay? Those steps, if you write them down, will help you. Write the minuend. Write the subtrahend. Make sure you've written it as a subtraction problem because then you're going to flip all the signs by adding the opposite. Example 4. You can also do this in the horizontal fashion, but I don't like it. I'll show it to you. If you like it, great. If you don't, I don't care. You choose how you wish to do it, whether you want to perform it up and down or you want to do it this way. Here's example 4. X squared plus 4x minus 9 minus 4x squared minus 5x plus 11. First, verify that you copied it correctly. Making sure I did. Okay. Second, instead of lining it up horizontally, we are simply going to add the opposite of the subtrahend. This is the subtrahend. Add the opposite. Add the opposite. Add, this is now a negative sign. Okay? Now that I have changed all the signs, I can do the combo of the colors like I did in the first example. Let's combine our x squareds. A positive x squared and a negative 4x squared. What do you get?
2x squared.
Negative 3x squared. Combine your x's. A positive 4x, and now this is a positive 5x. So you get a positive 9x. And lastly, combine your constants. A negative 9 and a negative 11. There's your answer. Okay, I don't care how you do it. Horizontally or vertically. Horizontally is right, left. Vertically is top, down. Up, down. Okay. Example 2. This is a real-life application of something like this. You are saving up for a trip to Costa Rica. You deposit $400 or $500 into an account that earns interest compounded annually. 1 year later, and I'm leaving space because I'm not sure what I got here, I am depositing another $600 that is deposited into the account. Let R be the annual interest rate. What is the balance? And they're calling the balance A, otherwise known as the answer. What will the balance be in the account after 2 years? Okay. For For the savings account described, balance from the first deposit. What? You guys haven't even learned this yet.
Yeah, we did it a long time ago. Compound?
You guys haven't learned that yet.
In chapter 11?
Yeah, we did.
The chapter that was skipped?
No, we did it a long time ago. Can't remember when we did.
You guys didn't learn this yet. It's not in this book. All right, you know what? I'm going to skip that one.